And welcome everybody. Holy shnikers, it's great to have you here. Today we're going to focus on VPNs, give you a little behind the scenes look. That's what we do here on Wednesday, is just to give you a little bit of insight on what I'm creating and some of the cool stuff that's coming out. And so today, based on your votes from last Wednesday, we're going to do VPNs today. And then just so you know, coming up every Sunday at 11 a.m. Pacific time, it is CCNA Sunday. But it gives us an opportunity to cover a lot of the topics of CCNA. I plan on doing that. I've got about 3 months of Sundays lined up to present amazing stuff from the current and new CCNA, mostly the new CCNA, but all that content is still relevant going backwards. So this Sunday coming up is layer 2 switching, and we won't cover all of it because there's so much that can be done with layer 2 switching. We have things like VLANs, we've got things like trunking, we have inter-VLAN routing and everything else. So a lot of fun coming up, but I would like your opinion for what you'd like to cover next Wednesday. So Wednesdays at 4 p.m. Pacific. That's what I'd like to know. What do you want to cover? And so here are some choices I have for you. And let's take a look at those. And they are here. There we go. So December 18th, next Wednesday, a week from today. What would you like? I've had a few requests for port security, but every time I put it for a vote, it doesn't get the majority vote. So I'm still hoping. I'm going to keep those in the queue. I appreciate the feedback and the input. So these three are the three choices I'd like to focus on for next Wednesday. And that is port security, or B, inter-VLAN routing with a multi-layer switch. I'm amazed at how many people are, especially new people to Cisco, which is what I'm working with here, very interested in how that multi-layer switch works and how they can pop a logical layer 3 interface into a VLAN and poof, route. It's amazing. Or option C, I can give you a behind-the-scenes look at the assessment labs that I'm creating at CBT Nuggets, which I'm really excited about. More to come, especially next Wednesday if that's what you select. So let me know either by letter or by title, port security, inter-VLAN routing with multi-layer switches, or assessment labs, and we'll do that next Wednesday. And if none of those sound appealing to you, that's cool. We'll have something else the following Wednesday. And again, this Sunday, which is the date is the 15th, we're going to focus on layer 2 switching. So if you want to join us for that or catch the recordings of that, that's super. All right, I've also want to thank Jake, who is helping me moderate today. And as always, for those of you who are seeing your fellow humans' questions and you're chatting them in and you're answering those to help them out, my hat's off to you. Actually, there's 3 or 4 people that have been consistently helping other people out, and I really appreciate that. That's what this is all about. So having some fun, making progress in the right direction, and learning as we go. So anytime you can help somebody out, I appreciate it. So today, I want to chat with you about VPNs, because that's what we voted for last week. And let me share with you this. I'm going to bring up another window over here so I can see exactly what I'm sharing. I'm glad you checked, because otherwise you'd be watching me. Here we go. So this is the back-end studio at CBT Nuggets for some of the VPN content I've been creating as part of CCNA. So what I'd like to do is share maybe 3 or 4 of these with you. They're all fairly short, and so let me introduce VPNs verbally myself, and then we'll go ahead and we'll start with the next one, the VPN overview. I don't know what it is, but there's something about privacy that people want to maintain. And so if we have data that we have on a hard drive and it's being stored there, if somebody steals that hard drive like this is a great example. This is a device, Raspberry Pi, has a hard drive or a flash drive I can store data on. And if I store data on this and somebody physically steals this, that data is not protected in any way, they can just read the data. Same thing with a mobile device. And so to protect data, we encrypt it. Now, encrypting is just a fancy way of saying we're taking the data and we're scrambling it with some kind of an algorithm, a set of rules, and a key, so that the combination of that key and the actual algorithm makes it so that somebody who doesn't have the key can get the data, but they can't make sense of it. So that's called data at rest. It's like at the end of the day when your data is tired, data at rest is referring to data sitting on storage. Could be in the cloud, could be on a physical device on your location or in your house. But data at rest, we want to have it encrypted to protect it. Also, what about data on the way? If we have data that's going over a network, we also want that protected and keep it private. So we also use the mechanisms of cryptography, which is a fancy way of saying the hiding the data so that if people just steal it off the wire, eavesdrop on it, they can't make sense of it. And that's the major concept of a VPN. So in corporations, we use VPNs to protect the data going back and forth, but we can also use VPNs as individuals if we don't want our internet service provider or we don't want traffic that's going over untrusted networks to be intercepted and interpreted. So I'd like to share with you a few of these videos regarding VPNs. And then if there's any questions that Jake wants to bring in, we can go ahead and have him bring in those as well, including the vote for next week. So let's launch this one first. And I will lower the speed here.
We send millions of packets every single day.
Oh, it's way too fast. Way too fast.
And if we want to, we can add a little extra protection as those packets cross the internet by using a technique called VPNs, virtual private networks.
All right, so that's what, when I'm reviewing my own content, I usually go at 2x because I know what I've already said, but I'm going to slow it down to 1x for this presentation so we can all appreciate it together. Let me line this up and enjoy.
We send millions of packets every single day across untrusted networks, such as the internet. And if we want to, we can add a little extra protection as those packets cross the internet by using a technique called VPNs, virtual private networks. And that's what you and I are going to discuss in this video. So let's use this topology to talk together about when it might be appropriate or really useful to have that extra protection of a virtual private network as we send traffic over other people's networks, including the internet. One of those situations is if we have a remote site that wants to communicate with the headquarters site over somebody else's network or over the internet. So the problem is that if we start sending packets over the internet that are just plain text, they're not encrypted or kept secret, anybody and any service provider or any router that's forwarding that traffic on the internet has the opportunity to eavesdrop on that traffic or possibly manipulate that traffic, which would compromise our security for the communications between those two sites. So in this case, what we could do is we could build a logical path, they call it a VPN tunnel, between these two endpoints, between the router at the headquarters site and the router at the remote site. And here's what happens. Anytime traffic from the headquarters site is being routed to the remote site, the router is going to pause for a second just for that specific traffic and say, whoa, I'm going to go ahead and take a moment and I'm going to encrypt the traffic, make it protected, and logically send it through this tunnel. So when we say it's going to send it through the tunnel, what that means is that this router is going to encrypt the traffic and ship it over to its good buddy over here at the remote site so this router can decrypt it. So from the internet, it just looks like packets that are being sent, but behind the scenes, the payload of those packets is encrypted. So if we have any malicious actors on the internet who want to eavesdrop on that data or they want to manipulate it, they won't be able to do it successfully because the data is being encrypted by this router and then decrypted by this router, and only those two routers, being the endpoints of this VPN tunnel, have the ability to decrypt or make sense of the data. And this VPN tunnel is sometimes referred to as an SA. That's an acronym for a security association between this router on the left and this router on the right. And this type of relationship between these two routers, where they both agree to take traffic between these two sites and encrypt it and ship it to each other, that's referred to as a site-to-site tunnel or a site-to-site VPN. So if somebody asks us, well, how do we protect traffic between this site and that site if it's going over the internet? The answer is we could set up and configure a VPN site-to-site tunnel, which would encrypt and protect every single packet going between those two sites. And that's how we could do it, with a site-to-site VPN tunnel. Now, another scenario that we might want to use the VPN protection on is for an individual computer. So here we have Bob. Let's say Bob's at his home and he's got his PC connected to the internet. Perhaps he's using cable modem or DSL or some other method. He's connected to the internet, but if he wants to connect to the headquarters site, we don't want him sending packets just naked and unencrypted either, because once again, they could be intercepted or eavesdropped on by devices on the internet. So once again, we could build a VPN tunnel here from Bob's computer individually over to some device at the headquarters site. So to build that VPN tunnel from Bob's computer to the headquarters site, on Bob's computer we'd have software that he's running that would allow him to do that. And then at the headquarters site, we could have a device such as a router acting as the other end of that VPN tunnel, or we could have an ASA or a firepower appliance. Any one of those devices if properly configured, could be the device at the headquarters site that Bob is using to connect to with his personal VPN. And when we build a VPN from an individual computer, that's called a remote access, or RA, VPN. So these are the two main categories of VPNs: site to site, for example, between the headquarters site and a remote site, and a remote access VPN, which is being started from an individual computer going to some other device, in this case a router at headquarters site, to build VPN protection for traffic from this user as it communicates with the headquarter location. So now, if somebody came to us and they said, hey, how do we protect packets as they go over other people's networks or untrusted networks, we could say we could implement a virtual private network, a VPN. And furthermore, we could say, you know what, there's two kind of categories of these. One is called a site-to-site VPN, if we want like site 1 to site 2, and all the traffic between those two sites to be encrypted and protected, we'd use a site-to-site VPN. And if we need to protect data from one individual user on their own PC, we would create a remote access VPN that starts at that PC and ends, in this example, at the headquarters site at the other end of that VPN tunnel. So now we know the two major camps or categories for VPNs, site-to-site and remote access. And in the next video, what I'd love to do is chat with you about some of the building blocks of cryptography. This is a fancy way of saying how VPNs protect each of those packets. And we'll cover that in the next video. So I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.
And with that said, here's the next video.
Maintaining confidentiality and privacy is important, and those are some big things that are brought to the table with a virtual private network. When we're sending packets across the network, or across the internet, or some other untrusted network, we absolutely do not want just anybody who sees that packet to be able to open it up and make sense of the content. Because if we have secrets that are company secrets, or sensitive information, or protected information like health information and so forth, we just absolutely shouldn't leak that information or make that available to unauthorized eyes. So to accomplish the feat of VPNs, virtual private networks, as we protect and encrypt every packet as it's being sent over these untrusted networks, we're using some techniques from a suite or a technology called cryptography. And that's what I'd like to chat with you about in this video. So the root of the word cryptography came from the concept of having secure communications in the face of an adversary. So if you had General A, for example, from some army, and you had General B from the same army, and they were going to send messages back and forth, they would use cryptography to make sure that if those messages were intercepted, that the interceptor wouldn't be able to make sense of them. There was some kind of cryptography going on that would hide the actual message that was being sent. An example of this would be a Caesar cipher, as in Julius Caesar. That's what he used. So in the current day and age, cryptography refers to a bunch of algorithms or formulas and standards that can help us to also protect data. But there's two major goals with cryptography. One is confidentiality. In the case of two devices communicating over an untrusted network, if somebody intercepts the packets and they look at them, if they can't make sense of what they mean, the payload, we've just accomplished confidentiality. If only host A and host B can figure out what the actual message is, we've maintained confidentiality with our cryptography. And with virtual private networks, that confidentiality is implemented via encryption. And here's an example using the Caesar cipher of a protected message. And it was encrypted using some type of a key or method. And if host A and host B, or both parties, know what the key is, one can encrypt it and the other one can decrypt it. So the key here is it's a one character shift forward, meaning each of these letters is just one in advance of the actual letter. So if you back up each of these letters, the U would be a T, the I would be an H, and continued on. And if you want to solve this, go for it. Just back off every character to its previous character in the English alphabet, A through Z, and that'll reveal the hidden message. So that's an example of way back when of how we could encrypt a message, and only the sender and receiver who know the actual key or how to decode it could actually make sense of the message. And in today's high-speed networks, what we're going to use is an encryption algorithm, and one of the very popular ones is called AES, which is an acronym for the Advanced Encryption Standard, AES. And then there are several flavors of it as far as how many bits involved. And with cryptography, the general rule is size matters, meaning the bigger the better, or at least the bigger, the more secure it's considered to be. And the more bits that we're using as part of our algorithms, the more CPU and energy it's going to take to do the calculations. So if we had two sites, site A and site B, and they were connected over the internet, and we wanted to implement a VPN between them, we could train these two devices to set up a VPN, a virtual private network. We could tell them to do encryption. We specify the algorithm that we'd want to use. And if we set up this VPN, a question might come up, well, if we're using AES, which is a standard, couldn't just anybody jump in the middle of that with AES and interpret the data? So the secret is these devices that are at the endpoints of this VPN tunnel, they will negotiate and use keys that no one else knows about. So because host A and host B, or router A and router B, have the keys involved, only those two devices will be able to properly encrypt and decrypt the data. While anyone in the middle who eavesdrops on that traffic or wants to look at the data, they're not going to be in luck because they are not going to have the keys. Think of it like a trunk with a padlock on it. Basically, if you have the key to the padlock, you can open it up, you can close it, lock it up. But if you don't have the key, you're out of luck. So host A and host B have the key to that padlock, if you will, and everybody else does not. And that's what keeps our data confidential with encryption using current standards like AES. Now, besides just keeping our data private, we also want to make sure that the data isn't being manipulated or changed by unauthorized parties as those packets are being sent back and forth. And that refers to having data integrity. And data integrity is accomplished through a method called hashing. And we can kind of think of hashing like a little indicator to say whether or not the data has been modified. Think of it like this. Let's imagine I'm sending you this letter. So I've typed up this nice letter, and then I've counted all the characters that are in this letter. And let's imagine there's like 340 characters. So what I do is I take this letter, fold it up, put it in an envelope. I totally forgot what number I said. Let's say it's 425 characters. I put the letter in the envelope, close it, and then on the outside, what I could do is I could write a little note, 425, on the envelope. And so when you get it, you open it up, you take a look at it, and we can take just one extra step of saying, okay, I'm going to make sure I count all the characters and then match it against what you said the characters were, 425. And if the number's off, if you said it should be 425 characters, yet there's 450 characters, hey, somebody's tampered with our data. And as a result, we can drop it and not accept it. And that concept of data integrity for an individual packet as we send it over a VPN is referred to as hashing. And for hashing, the two major families for hashing are MD5 and SHA. Now with SHA, S-H-A, there's a whole bunch of flavors of SHA. Like there's SHA-1, SHA-2, SHA-256, et cetera, et cetera. But in either case, the objective of using a hashing algorithm is to verify data integrity, that nothing has been modified or changed in that packet that's been sent over the network. And as a fun example, here's a website, is toolsfornoobs.com, and it's got a hash calculator. I want to help reinforce the idea that the hash is just a teeny little add-on that helps verify data integrity. So I've got the Declaration of Independence in my clipboard. I'm going to right-click, and I'm going to paste it in. So there's the Declaration of Independence, and beautiful. So it's got all the words, all the characters, and if we want to generate a hash on this entire document, what we can do is we can select the algorithm. So let's use SHA-256, that's a nice strong one. And then we'll click on hash this, check it out. See this little teeny thing right here? This hash is based on the entire document. And if we change one character, just one, in the document, that hash is going to change. Instead of unanimous, we'll say majority. Of course, that's changing this document. And if we click on hash this, you'll notice if you go back in the video a moment, this hash is different. So the hash is a teeny little add-on that helps the receiver identify, did this data, did it get messed up or modified in transit, or does the hash match? So in this video, we've had the opportunity to take a look at how a VPN is protecting data. And it's protecting the privacy, the confidentiality, by using methods like encryption. Encrypting the data in a format so that any device without the right keys involved, they can't make sense of it. And the most popular encryption algorithm that we're using today for site-to-site VPNs is AES, the Advanced Encryption Standard. And then to verify data integrity, to verify that data hasn't been manipulated or changed in transit, we use a method called hashing. And the two major categories there are MD5 and SHA with lots of different variants behind it. But the goal of hashing is to verify that the data has not been modified as it's being sent over the untrusted network as part of the VPN. So now we know a couple building blocks for VPNs. The encryption aspect, which keeps the packets private or confidential, and the hashing aspect, which makes sure the data has not been modified. Let's take those two building blocks and take a closer look in the next video at the site-to-site VPN that's protecting all the traffic that's going back and forth between those two sites. So I'll see you there in just a moment.
Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing. This is a live cut-in for my video. All right, so I had a few questions that came up. I thought I'd want to pause for a moment and address those. I've got a request regarding a t-shirt. I will take that up with you privately and get you hooked up. Another question said, I just passed the CCNA security exam. Awesome. That means that in February 24th of 2020, they're going to give you the new CCNA. So any current CCNAs, regardless if it's wireless or security or anything else, they give you the new CCNA. So you'll have that. And then as far as going on, there's then the professional level track for security, which is not a bad way to go. What I would recommend for if you've just got your CCNA security in your, or if you're working for a company that's using certain security products, maybe they have Palo Alto firewalls, or maybe they have Checkpoint, or maybe they're using some other security device, I would say it might make sense to start studying that because you'll have more of an opportunity for hands-on practice and supporting it in that environment. In the event you're not working with an organization that has any of those security devices, or you're just building your skills, you're not working for somebody yet, continuing on with the CCNP level for the professional level for security is a great move. So just be aware there's other security products out there, and I would recommend going with the ones that you have closest access to. That would make the most sense. All right, another question. MPLS, the question says, are MPLS and VPN tunnel mutually exclusive WAN techniques? So great, so great. So what we're talking about here for security purposes is IPsec site-to-site VPNs, where you have two peers or more, and those peers, they basically take all the traffic and they encrypt it, ship it over the untrusted network. The other router, the other peer, decrypts it and passes it on to the final customer. That's using a suite of protocols called IPsec. And so as a result, we're doing encryption and decryption. Now, in a service provider environment, they've got a challenge. Let's imagine that you and I are a service provider and we have dozens of customers and they've got sites all over the place. Would it be important for us to make sure that if we have, let's take Acme Incorporated. If we've got a customer, Acme Incorporated, and they have two sites, one over here and one over here, it's important that when they send their traffic into us, the service provider, that we make sure their packets end up at the right location at their other site. We don't want to take Acme's packets and have them show up at the wrong customer site. That's going to be confusing and it's not going to make their site happy. And also we have a confidentiality issue by sending the wrong company's packets to the wrong destination. So in a service provider, we use MPLS, multi-protocol label switching, and techniques called layer 3 VPNs, but in that sense, it's not encryption. So layer 3 VPNs aren't for the purpose of encrypting or protecting and making the data confidential. It's for the purpose of making sure we get the data from the right customer site to the other right customer site. And so that's what MPLS layer 3 VPNs are about. Now on top of that, we could, at the edges, we could encrypt the payloads of those packets, and as they get switched to the service provider network, but that would be encryption above and beyond what the MPLS is doing. So it's a great question because the acronym's the same, VPN, Virtual Private Network, but the implementation and the purpose is different. In a service provider network with MPLS and layer 3 VPNs is just to get the right data to the right customers. With site-to-site IPsec VPNs, we're doing it purely for confidentiality as we're sending traffic over untrusted networks. So great question. And then there's a request for please do a video on OSPF types. You know what? I would love to. Here's my challenge for us. I'm going to add that. Every Wednesday, I ask, what would you like to see next? And so I will add that as one of the items. And so as I start to add that, the OSPF network types. Yeah. OSPF network types like broadcast, non-broadcast, point-to-point, and so forth. So I will add that next week as an option. And so if we can get enough people to vote on it, it'll come up in the queue and I will do it. So I don't know if I have a lot of current training on that, but I can create some. I'd be happy to do a live session on it. When I did CCA training, we had to cover those and I had to memorize them. Now I have to rethink and say, okay, how does that work again? Where would I use this? What's the implications on you have a hub and 4 spokes and the relationships. So I will add that as an option, and all we need to do is vote on it, and we'll include it. Also, what I'll do is I'll share the importance of that. It's really more of a CCNP and expert level content as opposed to CCNA, but I will I will reinforce the reason why that's really important, and that is if you want OSPF to work correctly in certain topologies like hub and spoke, it's critical, and based also on the type of network connectivity that you have. So I will add that. All right, thanks for those questions. Let's go ahead and take a look at the next video. And that next video is this bad boy on site-to-site VPN concepts. Hope you enjoy it.
I've always been intrigued by the concept of a site-to-site VPN. I mean, it's amazing. You have two sites, site 1 and site 2, and if they send traffic, or their users send traffic between those two sites, the edge devices, they take that traffic, they encrypt it, ship it over logically the VPN tunnel, protected, and the other side receives it and unencrypts it and forwards it on its way. It's amazing. So what I'd like to do in this video is take you behind the scenes on how a site-to-site knows what to do and some of the configuration options available for it. So using this topology, let's talk about some of the ingredients that might go into a site-to-site VPN. For data confidentiality, we're going to be using some type of encryption algorithm. For data integrity, we're very likely using some kind of a hashing algorithm or a set of rules. And then we can train these two routers, router 1 and router 2, that they are going to be peers, that we're going to set up a VPN or a security association between them. Now, a really good question to ask is that to set up a site-to-site VPN tunnel between these two routers, what are we actually using for the umbrella of the hashing and encryption algorithms that we're going to be using? And the technology we're going to be using is called IPsec, capital I, capital P, SEC, meaning or implying that we're going to provide security for each individual IP packet as it gets transmitted between the two VPN peers. So we'll be using IPsec. Now, one great question is, how can a technology like IPsec, how does it stay current? Because I was learning about IPsec like 30 years ago, and it's still around. So how is it still current and viable? And the answer is IPsec is like an umbrella. It's a collection of protocols and utilities. And as new protocols come up, IPsec can adopt those. So long time ago, we had encryption protocols like DES, the data encryption standard, and then triple DES, which was even more secure. And now we're using AES. And as we have new encryption standards, we simply start to not use the older ones. So IPsec over the years has the ability to use any of these encryption standards. And as they get better and better, IPsec will adopt them. Also, we have some evolution in the world of IPsec. There was a thing called IKE. Originally, we had IKE version 1. IKE stands for Internet Key Exchange. There will not be a test on that later. But IKE v1, and as time went on, we have IKE v2. And either one of these methods as part of IPsec can be used along with the encryption and hashing algorithms to provide security as traffic is traveling between R1 and R2. So what I'd like to do right here with you is take a look at what happens between the two VPN devices that want to establish a tunnel, a security association between them. I want to share with you what happens with IKE version 1 behind the scenes. And here it is. These routers would be configured, and what they would do is they would set up and they would negotiate what's called an IKE phase 1 tunnel. This IKE phase 1 tunnel is being used so that R1 and R2 can securely talk to each other. So if they need to communicate directly to each other, they can send the data logically into the encryption and hashing algorithms that are part of the phase 1 tunnel. This is also sometimes called the ISAKMP SA. Now, ISAKMP is an acronym. You don't need to memorize the acronym, but it's an acronym for the Internet Security Association Key Management Protocol. And SA is an acronym for Security Association. So they'll build this tunnel, and for this tunnel, they'll have negotiated and agreed upon things such as which encryption algorithm are we going to use, what hashing algorithm are we going to use, and also the keys involved. They can negotiate keys dynamically so that only R1 and R2 have the ability to lock and unlock the data respectively. And after R1 and R2 establish this tunnel that they can use to communicate with each other, they then go to work and they build a second tunnel. What, Keith? A second tunnel? Yeah, they build a second tunnel, and that's for users traffic, like Bob. So if we put Bob over here, and we put Lois over here, for the actual traffic from users at site 1 going to site 2, when that traffic hits the routers are going to encrypt that user data and ship it logically over the tunnel to the other side, who will then decrypt it and forward it on to its intended destination. And this second tunnel is often referred to as the IPsec SA, or we could also call it the phase 2 tunnel. And it's not likely that in one given sentence they're going to refer to either of these tunnels by all of their possible names, but I wanted to share with you where they fit. And for this IPsec tunnel, which is going to be used to encrypt the user's traffic going back and forth, They will also, the router 1 and router 2 will also have negotiated what type of encryption they want to use for that tunnel, the hashing that they want to use for that tunnel, and other parameters that are applicable, including what traffic to encrypt. I mean, if this is the site 10.16.0 and over here is 10.16.8, part of the rules for the tunnels would say, okay, only encrypt traffic if it's coming from 10.16.0 and going to 10.16.8. So if Bob's trying to go to ESPN or some other website or Twitch or whatever, when the router sees that traffic, he'll look at the source. It's coming from 10.16.0, but it's not going to 10.16.8, and as a result, it can do a NAT. It's probably going to use NAT at that point, and then forward it out to the internet and not send it through the tunnel. So in this video, we've introduced the concept of IPsec, which is a huge umbrella that covers a lot of sub-technologies, including hashing algorithms and encryption algorithms. We also identified that two routers that are running IPsec, they are going to establish relationships with each other. We call those security associations. And as part of that, they're going to negotiate the encryption they're going to use, the hashing they're going to use, and depending on the version or flavor of IPsec and the site-to-site tunnel, we could have an IKE phase 1 tunnel, where the two routers are just talking to each other directly, and then a second tunnel, a logical tunnel, that's going to be used to encrypt and send the traffic from users like Bob and Lois back and forth, encrypted, safe, and private over that tunnel. And what I thought would be fun to do is, let's take a look with a network analyzer to look at the actual packets, and we'll take a look at what the packets look like before they're encrypted and after, just to verify that traffic that is going through the tunnel, that those packets are being encrypted and protected and shipped over to the other side. So I'll see you in that video in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.
All right, and let's bring up that video. Here it is.
In this video, let's have some fun by turning up IPsec with the site-to-site VPN tunnel between two routers, and then for the primary purpose of looking at the traffic before it gets encrypted and then after, just to have a very visual comparison and realization that, oh my gosh, this traffic, once that router gets it and encrypts it, it's not understandable by anybody who doesn't have the appropriate keys to unlock that data. Let's use this topology as our backdrop. Now, there are a lot of individual things that need to be planned for and implemented and configured for an IPsec site-to-site tunnel to work. Now, in this topology, most of that has all been implemented short of one thing, and that is a crypto map. And you might ask, Keith, what is a crypto map? I'm glad that you asked. A crypto map is a collection of the settings and attributes that we want to use for our IPsec tunnels. And what we do is we create a crypto map along with the other details for IPsec, and we'd apply that crypto map to the interface here. So the interface here that R1 is going to use as it communicates to its peer over here, R2, is interface gig 2/0. So we'd apply the crypto map here on this interface, we'd apply the crypto map here on R2, and that would bring together all of the policies and attributes with the hopes that we're going to build that VPN tunnel between those two sites, assuming that all the other details are in place. And once we've applied the crypto map and there's traffic that needs to go from 10.16.0 to 10.16.8, if we're using IKE v1, we can do a show command and we can take a look at the tunnels. We can do a show, crypto, isocemp, SA, and that's going to show us our IKE phase 1 tunnel and the details about it. And if we want to see the second tunnel, that's the tunnel that's actually carrying user traffic, we use the command show, crypto, IPsec, SA. And one other command while we're here is a show crypto engine connections active. And that also will give us a bird's eye view. We could also do a show crypto map. There's a little space right there between crypto and map. And the show crypto map will show us the details of the crypto map, including whether or not it's applied to an interface. So let's get back to our point of what I wanted to cover in this video, and that is, what would it look like to look at the traffic before and after it's encrypted? So let's do this. So for our plan, let's do this. Let's take a PC at 10.16.0.10, and let's have it ping a device over here at 10.16.8. And let's go ahead and pick on 111 as a target that exists over there. And so if this device is pinging that device, and we have our IPsec tunnel that's built that says encrypt everything from 10.16.0 to 10.16.8, if we capture the data right here before it hits the router, we should see unencrypted data. If we capture the data right here after the router, we should see the encrypted packets. But we'll see that they're encrypted, but we won't be able to look at the payload and make sense of what's actually being carried inside of those IPsec packets. And if you'd like to join me in this, please do. This is a hands-on lab, so you can go ahead and click on the link for the virtual lab and follow right along with me. So we'll open up MT Putty in the upper left-hand corner. And let's open up a connection to R1. And we'll also open up a connection to R2. And let me go ahead and press enter a few times to clean up the screen a little bit. Fantastic. So here on R1, if we did a show crypto ISACEMP SA and pressed enter, it's going to say you got nothing. There's no tunnels in place. And if we did a show crypto IPsec SA, it's also going to say we don't have any security associations for IPsec tunnels either. And let's do one more command. Let's do a show crypto map. Press enter. And although there's a lot of output here, basically this crypto map called our map says that if traffic is sourced from 10.16.0 going to 10.16.8, it's going to go ahead and encrypt that traffic. And as far as the encryption and hashing it's going to use for that traffic, those are specified right here. And down here it says the interfaces currently using that crypto map is nothing. So what we're going to do is we're going to go to interface gig 2/0, and then we'll apply that crypto map. So all the other heavy lifting has been done. All we need to do is enable the crypto map on this router, router 1, and also on router 2, and that will enable the feature. Now, before we do that, let's also bring up our client PC, and let's just verify that we can ping and have connectivity before we put on the IPsec tunnel between R1 and R2. So we'll log on to the client PC, and here on the client PC, we'll bring up a command prompt, and at the command prompt, let's do a ping, and I'm going to do a -T, which means continuous, and we'll ping 10.16.8.111 and press enter. And now our ping is going. We'll let that go. And while that's running, let's go ahead and enable IPsec by applying the crypto map to both R1 and R2. So back to DCNUG we go. And here we'll go to configuration mode, interface gig 2/0, and use the command crypto map and the name of our map, which is right here, our-map in uppercase. Boom, that is done. And next we'll go apply it to R2. So the interface on R2 is going to be gig 00. So we'll do config T, interface gig 0/0, and crypto map space, and I also named it my map over here as well. My-map, and press enter. I guess I didn't call it my map. I guess I called it our map. All right, let me try that. OUR. There we go. Perfect. All right. So now we've enabled the crypto map on R1 and R2, and there should be in the background the IPsec tunnel being built and set up. And hopefully, if that's working correctly, the traffic from the client is now going again. So if we go back to our client PC, we'll notice that it had a little bit of a timeout while it negotiated and brought up the tunnels. But now all this traffic is being sent as it goes between R1 and R2. It's being sent through this logical tunnel, with each and every one of those packets being encrypted with IPsec. And I'm going to do a Control-C a couple times to cancel that ping. And let's go back to DCNUG, and let's take a look at our tunnel information. So if we go back to R1, we have a couple commands already cached. So let's try those again. So if we hit the up arrow key a few times, one of those is show crypto ISACEMP SA. That's looking at the IKE phase 1 tunnel. So if we press enter there, look at that. So we have this tunnel that's currently set up and active. And if we hit the up arrow a few more times, we have the show crypto IPsec SA. And that's going to show us details about the IKE phase 2 tunnel, or the IPsec tunnel, including how many packets have been encapsulated and encrypted, and how many packets have been decapsulated and decrypted. And while we're here, let's do one more command. Show crypto engine connections active. And so this represents our IKE phase 1 tunnel. This represents the security associations for our IPsec tunnel. There's one in each way. And I would guess for this one, this is a failed one that never worked out. And that's because we brought up R1 first. The pings were going on, but R2 wasn't ready. So it timed out, wasn't working. And then it tried again and actually was successful in bringing up the tunnel. And this is super fun. This is a packet capture on the connection between router 1 and router 2. And so before we had the IPsec in place, we had these pings that were sourced from 10.16.0.10, our PC, going up to 10.16.8.111. And then finally, when we enabled IPsec on R1 and R2, it started negotiating the tunnels. So when we see main mode here, that's negotiating and setting up the IKE phase 1 tunnel, and the quick mode is setting up the actual IPsec tunnel itself. And then once the IPsec tunnel is set up, these packets right here, look at them. They are ESP. ESP stands for Encapsulating Security Payload, and it is a layer 4 protocol, and it is protocol number 50. And that's the protocol that IPsec uses as it encrypts, encapsulates. So originally, before the encryption, we had 10.16.0.10 to 10.16.8.111. It was an ICMP echo request. But after the encryption, it just looks like packets that are going from R1's address here, that's R1, to R2's address here, and anybody eavesdropping, they'll see it's an ESP packet, it's protocol 50, but the payload is all encrypted. They don't know if it's an ICMP request or an SSH session or a website request or anything else, because the entire payload is protected and encrypted due to IPsec and encryption algorithms that are protecting that data. And when these packets are received by R2, R2 would take those packets, decrypt them, and then forward them on to the final destination. So the host at 10.16.0.10, they really don't know that in between R1 and R2, the traffic was encrypted and protected, nor do they really care. They just got the packets back and forth, and they were happy that it worked. So the intent in this video is to help reinforce the concept that when traffic goes through a VPN, it is encrypted and hashed and protected with whatever algorithms or protocols are being specified by that site-to-site tunnel, all under the umbrella of IPsec. So in this lab, have some fun. If you want to apply the crypto maps as we did in the demo, that's great. If you want to practice a few show commands, that's great to get a kind of a warm-up to the idea of IPsec tunnels. And I'll see you, my friend, in the very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.
All right. Well, it kept my attention. I have a few questions that came up in the queue. Thank you very much, Jake, for forwarding them. One was asking about what Linux certs are seen well by the market. If you're, I think that at an entry level, the CompTIA has, they probably call it Linux Plus, but it's fairly new. So the CompTIA Linux certification is a great one. I've talked to Sean Powers about it. He feels like it's a really super exam, really testing for basic core knowledge. And also, Sean Powers would be the guy to ask about. He's like an expert on Linux. He loves teaching it. So if you can find him at like Brain of Sean, if you on Twitter or whatever your social media is of your choice. If you search for Sean Powers of CBT Nuggets, I think his website is Brain of Sean, something clever like that. He'd be another person to ask as well. But the CompTIA Linux Plus course, I think, would be a great start. Another question was from Philip asking, can it be restricted by the port also, or do you use the full range? And if you could, Philip, elaborate on what that question was regarding, and I'd be happy to answer it. I'm just not sure exactly what the context is. And then Stephen asked, are the two tunnels part of security? Okay, so for such as not keeping your password and username on the same sticky note. So for IPsec, the two tunnels, the first one, the IKE Phase 1 tunnel, is like a private party line between the two routers. So if we got this guy and, hold on a second, and this guy, and they're building they're doing an IPsec, and they're setting up everything. The IKE Phase 1 is like a private party line just for them. They want to talk to each other. How you doing? Doing great. Hey, it's time to rotate the keys. Okay, great. Or we need to negotiate this. That IKE Phase 1 tunnel is just for their personal communications between the two VPN peers. And then, with that in place, they set up the other IPsec tunnel, the second phase, the Phase 2 tunnel. And then when they have to encrypt and decrypt data on behalf of users, they use that tunnel. So that's just the way they set it up. I suppose it is more secure. I'm not a mathematician or a math scientist or a cryptography engineer. I don't write the protocols, but I imagine that when they wrote it, they did it with the interest of making it as secure as possible, and also the ability for the two VPN devices to have a private party line so they could renegotiate or readdress other issues that are on the other tunnel. All right. Oh, great. Another question. Asking, what do you have in the lab equipment? So let me it'd probably take me 2 minutes to bring up a lab. So for CBT Nuggets, what we do is we have some lab environments, and they're purpose built. They're not full-fledged, do everything you'd ever want to do, go have a party up there in Cisco iOS land, but they're more focused on the topic at hand. So in this case, I was teaching VPNs, or it's really an overview of VPNs. So it's an environment that supports the IPsec commands and the show commands for Cisco for IPsec. And so that also is true if we're teaching layer 2 switching or trunking or VLANs. All the commands and syntax and output is what you get on physical gear, except this is a virtual environment and a lab environment. So a lot of people like to build labs. That's great. Back in the 80s, Cisco, back in the 90s for Cisco, I had to get equipment because there was no other option. But now there's options for Packet Tracer, which is free from Net Academy from Cisco. There's Viral, which is $200 a year, I believe, currently licensed product that can just do everything. There's GNS3 that's optionable, that has an even G if you have the licenses for the Cisco iOS that are out there. What am I missing? I think I'm missing one more. Viral? Even. I'll probably think of it right after the live stream ends. But the key is, especially at the entry level for CCNA, the secret is getting hands-on practice to get the practice. And I was talking to some Cisco engineers, and one of them had just recently come on board at Cisco, just got their CCNA, and he had been studying all the commands for, show commands and configuration commands to make routers work and switches work. And it occurred to me that it doesn't really matter if it's feedback that's live, that's meaningful and like it would be in a live environment. Whether it's a simulator or emulator or live gear, if you're getting the hands-on practice, the key is getting the hands-on practice, because then you can take those skills and apply them anywhere that they're needed. So great question. All right. Let me take a look and verify what our choices are for next week. And I believe that is right here. All right. So the majority vote, last time I got an update from Jake, the last majority vote was for the inter-VLAN routing with multi-layer switches. I'm going to ask Jake if he can confirm that for us. If he does, that is going to be our topic on Wednesday, December 18th at 4 p.m. Pacific. And this Sunday, CCNA Sunday at 11 a.m., we're going to focus on layer 2 switching and some fundamentals there as well. So, all right, still multi-layer switch, inter-VLAN routing. Okay, so that's what we'll do. I appreciate you joining me for these behind-the-scenes look at the skills that we're creating, and I love teaching. I appreciate your participation. If you have a friend or two that are interested in entry-level IT or considering Cisco certifications, even though I have taught at the IE level, I really, really enjoy helping people at the beginning and intermediate levels, the CCNA and professional levels, to really get a foothold, because my goodness, once a person kind of says, oh, I get this and I understand it, the opportunity to accelerate that and grow and continue growing is just almost endless. It's fantastic. So thank you very, very much for your participation and your involvement. If you haven't already, go ahead and click on subscribe and also hit the alert bell so you can get alerts when there's new live streams, new content coming out. And if there's topics that you'd like me to cover, let me know if they are. I'll put them up on the voting board on Wednesdays, and we can get a majority vote. And if there's enough people that vote for it, we will do it. If I don't have content already made for something that we all want to see, I will create it. Not a problem. Easy to do. All right. So on behalf of myself and Jake, thank you for the help in the background with the queue. I hope everybody has a great rest of the day. And I'm gonna let me find out some really cool music to say goodbye on. This is it's called Happy and Hopeful Through the Static. Thanks, everybody.